Here to speak to us tonight is a fellow engineer and a man who has quite literally defied gravity, is Colonel Chris Hadfield.
Il est devenu une véritable vedette planétaire grâce aux centaines de photos qu'il a publiées sur les réseaux sociaux depuis l'espace.
Good evening, everyone. And thanks very much to Dean Yip and to Claire and to Sam and Mark for the introduction. The whole idea of turning yourself into someone who can do something that's impossible, that's what defying gravity is all about. You know, breaking a law that is unbreakable, doing something that has never been done before, trying to turn yourself into someone that right now you can barely even allow yourself to dream of, like that. That's what I was dreaming about when I was an engineering student, thinking about someday defying gravity, even before I was an engineering student, when I was just this little engineering student right here. In my grade 5 school picture. Excellent sweater choice that day. What were you thinking about when you were 10 years old? You know, what goals were you giving yourself? What were the influences on your life? And for me, I was growing up on a farm not too far from here, but my head was full of the edges of possibility. And it was inspired by a confusing mixture of fantasy and fact, of comic books and Star Trek and 2001: A Space Odyssey and all of those crazy enabling ideas that were out there. But also with the practicality of people actually doing things. But I didn't see, and maybe for the students that are in the room, the link between where you are right now and the stuff that you hope might happen at some point during your life, it can be really hard to build that link. And in my case, I didn't see it until a guy who graduated with a degree in applied science took this picture. A guy named Mike Collins. Mike had just gotten his two buddies dressed, Neil and Buzz. And Neil and Buzz were in that little ship on their way down to try and do something that no human being had ever done before. Something that had just been a crazy fantasy of looking up into the sky, to try and walk somewhere besides the earth. And for that little boy, this link between the sort of randomness of a general vision of what might someday happen, and the reality of people actually doing things, that was super important in my formulation of what it was that I decided to try and do with my life. And I was born in Sarnia, and when I was looking for inspiration, you go to the next slide, oh there we are, I got it. When I was looking for inspiration and roles or role models that I could point myself to, I focused on this kid here. He was also from Sarnia. His name's Owen. Owen grew up in Ontario, and he went on to be the chief engineer of the lunar lander. That little ship that Neil and Buzz are in right there, going down to the surface, it was actually conceived and designed, the mission design as well as the mechanics of that ship, those were designed and taken care of by a University of Toronto engineering grad, Owen Maynard. And for that little boy to see someone who came essentially from the same place that I came from, who had turned himself into someone who could make something as miraculous as that happen, it wasn't just inspirational, it was enabling. It was like, if he can do that, then the only thing that's really stopping me from doing that is myself, is my own decision making. But there's risk involved. If you truly want to do like Neil and Buzz did and push the edge of what is absolutely possible, it was Buzz took this picture. He stepped forward, stepped back, leaned over with his Hasselblad, took that picture. You have to not only visualize something impossible and then sort of have a recognition of the necessity to constantly change yourself, but you also have to be willing to take the risks involved. And that's what these three guys did. Neil, he's an engineer out of Purdue, an aeronautical engineer. And Mike got his at the military academy, the Naval Military Academy. Buzz has a PhD in engineering out of MIT. But those three guys had to take the raw material of who they were and through sort of relentless education, give themselves a set of skills that no one had ever needed before. And then the three of them find a way to work together that no three individuals could do. And the impact was enormous. In the United States, there were more technical PhDs per capita in the 10 years after Apollo than any time before or any time since. People looked at those three guys and said, if they can do it, then maybe I could do it. If they can push dreams right to the edge, then so can I. And those three guys truly defied gravity. And it was hugely inspirational and enabling for me. I thought, they learned to fly, I need to learn to fly, so I joined the Air Cadets. I was 15 years old when I got my glider license, 16 when I got my powered license. You're gonna find, for the students that are here, that there's a sweet spot that will occasionally occur in your life when you're doing something that is super interesting and challenging. And while you're doing it, you're learning all kinds of new stuff in order to do this job right. And you're serving something larger than yourself. You're trying to improve life for humanity in general, the overarching aim of the program here. And you're taking care of your family. And for me, I went to the military academies. It was in the 70s, so I grew a mustache. Thought it was important at the time. I went to Royal Roads and then RMC and University of Waterloo and University of Tennessee, and I became a fighter pilot, serving my country, learning at a heck of a rate, challenging myself right to the limit. But I realized that if I truly want to do what I was dreaming of, to be that almost insurmountable goal of being an astronaut, it was going to take more than that. I got selected, went to test pilot school down in the high desert of California at Edwards Air Force Base. And after all of that, and you'll find this, of course, when you're chugging away at your own life, and then something happens, an opportunity or a window opens briefly, and the necessity and the willingness to take a risk and change direction and notice when fate slaps you in the side of the head. Because after I'd finished test pilot school and was a test pilot on exchange with the US Navy, this appeared in the newspapers all across Canada. And we used to have this thing called want ads. And it was weird. I mean, there wasn't any internet at the time. You're just, sitting at the breakfast table, and you're kind of irritated with your current job, and you're flicking through the want ads. And if you're in the back and you can't see it, it basically says, wanted astronauts. For that little grade 5 boy in the bad V-neck sweater, this was my ticket. This is what I'd been waiting for. And I'd been working on my own skills long enough that I could stick my hand up so high that they picked me out of a whole bunch of people that applied and sent me down to Houston, Texas. And look at those faces. Those are, they're a mixture of scientists, engineers, and medical doctors. But they're just a bunch of little kids from all around the world with different languages and different religions and different cultures, but all of them unified by a vision of a better world. A vision of pushing the edge of human engineering and capability, of hoping someday that if they can improve themselves enough, if they can have that relentless dissatisfaction with their own level of competence, just a burning desire to get better at stuff, then maybe someday they'd have a chance to do this.
12, 11, 10,
It's louder than that, actually. I was part of the flight crew of the space shuttle twice. I left Earth twice in this machine. What do you see as... It's great. I brought my own cheerleading team with me. They're just warming up out there. What do you see when you look at that thing on the left? When I look at it, it looks sort of like a finished product, right? But when I look at it, I see like thousands of little engineering ideas. That's all it is. Someone had a cool idea, like how are we going to protect it against the incredible heat of re-entry? Or how are we going to control this thing with all of the weird conflicting aerodynamic demands in this through the thermodynamic environment coming home? This is just 10,000 really cool and innovative ideas bolted together that then allows you to do something that has never been possible before in history. The greatest lifter of humanity to space so far. 2/3 of everybody who's gone to space flew on board this machine. Risky, brand new, cutting edge, but an absolute testament to human inventiveness, human tenacity, and human curiosity to try and push back the edge of ignorance. But after about 9.5 minutes of this thing crushing you in your chair and shaking and rattling you, the engine shut off and you're weightless. And now you're confronted with what I think is the most important question ever. And that is, what are you going to do next? And it doesn't really matter what you've done so far. You can't change any of it. And the stuff that's in the future, that helps you set goals. But your life is truly just like the strung together sequence of the little things that you chose to do next. It's all it is. What am I going to do now? What am I going to do this afternoon? What am I going to do this evening? And we often forgive ourselves the little decisions. We think, it's just a little decision. That's all you ever have. And so it's really important to be deliberate. How are my decisions, the little things I'm choosing to do tonight, this weekend, how are they fitting in to the overall dreams that I have for myself and my life? And imagine if you'd just flown that space shuttle, it had just shut off its engines, and now you're in the truly gravity-defying moment of weightlessness on board the spaceship. What would you do then? I mean, first you want to play with weightlessness. You want to unstrap out of your seat and float around. It's just so cool. You got to make sure the vehicle's healthy. About 500 switches in the cockpits. It's really the most complicated flying machine ever built. But what everybody wants to do is, actually, can you kill these bright lights for a sec for me, please? What everybody wants to do is get to the window and for the first time in their life, truly see the world. And this is just a glance out the window of a spaceship, where you can see the Great Lakes, and they look so immense, and at the same time, they're just these little shallow puddles that are sitting on the surface of the world. I think if you look closely, it's nice how Lake Simcoe points at Toronto. It's like, look at the bottom there. It's like, hey, Toronto's right over there. It's good if you're in space and you don't know where Toronto is. But you can see where Niagara Falls is, where the Niagara River splits, and it's just so incredibly instructive to see the world from up there. To look at the Finger Lakes, like some giant was just clawing at the earth just south of Lake Ontario and down to the Thousand Islands area. It's just so beautiful to get to know the whole world from a perspective that was impossible until you were willing to change who you are and take a risk. We're right closed in on Toronto. You know, there's this urban legend that the only human-made object you can see from space is the Great Wall of China. You cannot see the Great Wall of China from space. It's narrow and dirt-colored and follows the contours, but you can see the 407 from space. Yeah, it made me laugh when I took this picture, actually. And then if you look over at the 407, where it just bends up to the right there, just north of Downsview, you know, it's amazing what springs from this city. It's been 150 years that we've been gathering in buildings like this one to celebrate what we've done so far, to celebrate who we are, and to plan ahead for how we're going to do even more in the future. Just under the curve of the 407 there is University of Toronto Institute for Aerospace Studies and the Spaceflight Laboratory, which as a manifestation of the university defying gravity they've launched over 60 different satellites into space or been responsible for them. An amazing legacy of Canadian technological engineering achievement in space. And this is the biggest Canadian accomplishment ever in space exploration, in that we built the International Space Station. The Canadarm that was just put together all across the country and by the company up there in Brampton. This thing's huge. It's as big as 5 hockey rinks. It weighs 1 million pounds, going 8 kilometers a second. This huge laboratory of hundreds of experiments looking at the universe and using weightlessness to try and understand the fundamental nature of physics, and maybe most importantly, going around the world 16 times a day. So we're getting to know our planet like we've never known it before. And the complexity of this, started designing it in the 80s, parts of it by countries that are purely metric, parts of it by countries that are purely not metric. And, you know, in Russia, they use positive ground and 50 cycle, you know, and different, all the different engineering and computer standards. And the first piece was launched in '98. And so you never had a chance to actually integrate the pieces on the ground before it all launched. And yet it's been operating successfully with people on board for the last 22 years. An amazing outpost. It's also just a fun place to be. You know, where you can spill your water and have it float there next to you, or I wish we really could defy gravity just for a few minutes in here. Yeah. You know, we're all dressed up nice, but you'd have so much fun without gravity tonight. Flying around, these chandeliers would be hilarious without gravity. You know, winging around the room. We have no rooms like this on the spaceship. It'd be so much fun. You're the greatest gymnast ever, you know. Or you could just float to the window like Tracy here, the serenity of where you are, the peacefulness of. I've been around the world 2,650 times to get to know the whole planet, and not theoretically, but just as part of your own palpable human experience. It's what that little boy was dreaming of, to be able to see and understand the world this way. And U of T grads who have flown in space. Julia did a master's degree in electrical engineering here at U of T, and Roberta, who did her PhD in neuroscience at U of T as well. That came through this same enabling organization that the people who set it up 150 years ago were hoping for. Their dreams are no different than ours. They just want a better world for humanity. They want things to work for their kids and all their kids' kids. But it's also a huge responsibility with not just education, but with all of the structure that allows education comes a tremendous responsibility. How are you going to do the things that you're trained to do so that they serve society in a trustworthy way? How are you going to conduct your life so that you enable the opportunity for successive generations to do more than you were ever allowed to do or capable of doing? And it almost always boils down to, what are you going to do next? Are you ready for the stuff that's going to go wrong? Have you spent the time to change who you are? If one common characteristic of astronauts is just that pervasive, relentless dissatisfaction with their own level of readiness and competence. Always getting ready for the complexity that's coming and the necessity for internal change. I'm the only Canadian to command a spaceship so far. A wonderful responsibility to be able to take everything that I've been taught, all those people who all those years took time to explain stuff to me so that hopefully I would remember some of it, so the moment came I could maybe make the right call. And guide this group of people to be able to face up to tremendous difficulties, long distances away, incredible technical complexity, risking our lives together, but also the psychological side of things. How do we all agree on a common set of goals? Some of you are going to run entire companies, maybe even entire countries. And how do you gather the skills and then the people and the techniques and the capabilities to be able to do that? The common sense of purpose, the necessity to give everybody around you as many skills as possible. Any skill that exists in your team is an improved chance of success overall. The relentless necessity to do that. And then, just like the people that were cheering out in the foyer, to celebrate what's happening. Don't wait until Dean Yip is standing over here with the scroll and ready to hand it to you to try and celebrate the amazing process by which you have turned yourself into the person you are today. And it applies no matter what stage of life you're at. Have your goals, be constantly working on who you are to better able to achieve them. But notice just how cool, did you see how lovely it was in Toronto this morning? That was as beautiful a spring day as anybody could hope for. It was just gorgeous. I went around specifically for an hour just to look at new shoots of plants and flowers that are coming out of the ground. It's just there's a wonder of amazing, beautiful thing happening around us. And if you're worried about your blue check mark on Twitter, you could have a grim day today, staring at the little screen and missing the joy and the happiness and the amazing stuff that's actually going on in life. So put on Hawaiian shirts and have a luau. Why wouldn't you? Even if you're on board a spaceship. And sometimes things happen that are just so beautiful they almost defy explanation or description. I was Canada's first spacewalker, and to be able to put on this suit, NASA is really big on engineering, as you could imagine. And when they launch something into space, it has to exactly match the engineering drawings. It's a rule. Otherwise, you may have a configuration problem. So on the spacewalking suit, which built by the Hamilton Standard and the folks at ILC Dover, on the drawing of the spacesuit for launch, it has an American flag on the left shoulder. And so it has to launch for space with an American flag on the left shoulder. So you're the Canadian on board, and you're going to do Canada's first spacewalk. What do? You bring along a Canadian flag with Velcro stuck on the back. And when I got up to work, I peeled the American flag off with the Canadian flag. But do the honorable thing. I took my American flag that was on my suit, stuck it to the inside of the airlock, let it go down to vacuum so it was out in space with us. At the end of it, peeled it off, gave it to my American crewmate so he had a nice keepsake as well. But amazing stuff is constantly happening if you just remind yourself to notice. And because you go around the world every 92 minutes, you get a sunrise or a sunset every 46. And so you're in the darkness half the time, and I wanted to see Australia in the darkness, and so I shut off those lights that are up on my helmet there to give myself night vision. Speaking of which, can you kill the big lights for me again, please? And once I had my night vision and we were coming south of Australia, we went through the world's aurora. And I just could not believe it. I mean, I'd already gone through it a few times, but I'd been busy and had my lights on and my eyes were too small and I didn't notice. This is not a graphic. This is what it looks like when you are outside on a spacewalk and the aurora of the world is rippling past you and pouring around the ship and whipping between your legs with the red and the green of the little electron valence states hopping up and down and fluorescing. But it's just beautiful. It's otherworldly beautiful, and yet this is how planets work, and this is how it looks, and we would never properly understand it, or maybe even more so, we sure wouldn't appreciate it if we weren't willing, you can bring the lights up again, to visualize a better and different set of rules and opportunities that we have right now. And then identify the stuff that we don't know how to do yet, and then be part of the group of people who is working on those problems. If you're trying to decide what to do in your life, what pisses you off the most? What really irritates you? What's like, that shouldn't be that way? And maybe that's a good indicator to you of what it is that you should be working on, where you should be putting your shoulder to the wheel. We've discovered some stuff about the moon in the last few years that has really changed a lot of direction for spaceflight. The equator is super dry, drier than the Sahara, where Neil and Buzz walked around. But the poles, not only do they always have sunlight, because the moon sticks straight up and down in the solar system, but the craters are full of ice. And when we tally it up, our guess is there's about 400 billion liters of water in those craters. And so if you've got eternal power from the sun and you've got water, then you can live there. You just need a good habitat. It's like Barrie or somewhere. It's just, I love Barrie. Barrie's fine, But realistically, I think tonight it's maybe going down to -4 or -5 in Barrie. Without engineering technology, everybody in Barrie would die tonight. We sort of take it for granted, right? But our forebears, the engineers that went before us, the biggest discovery and thing that they figured out was how to harness fire. And then they figured out, shelter, and they figured out food preservation, and they figured out clothing, and all those things that we don't even think about anymore. But that you couldn't live in most of Canada if it wasn't for those engineering designs. And so that's where we're headed on the moon, because our technology is now just good enough. And this vehicle has launched without a crew on board. That's Artemis and the moon. It's already launched once with just to test the vehicle, make sure it was safe. And one of the little automated GoPros on it took this picture of Artemis Artemis, the sister of Apollo. Great choice of name for this program. Artemis, and then the moon in the foreground, and our little planet, the same one that Mike Collins took that picture of in the background. And there's a really cool announcement happening the day after tomorrow. We are going to announce who the next people going to the moon are. There's going to be 3 Americans, and there's going to be 1 of these 4 Canadians. One of those 4 on Monday is going to get announced as the very first human being who wasn't an American to leave Earth orbit. One of these folks is going to the moon. It's pretty cool, and I know which one it is. But I noticed, though, no mustaches in that picture. I'm not going to the moon. But to me, it's just so wonderful. This is a testament to the vision of people 60 and 70 years ago. How can Canada develop the capability and the technology and the proven operational ability, and then therefore build the trust so that we can be part of the leading edge programs that exist in all the different fields of engineering all around the world? And one of these 4 is going to get announced on Monday. But what's really changing spaceflight is the combination of so many different technologies coming together at the same time. Global positioning satellites, so we have super precise 3-dimensional positioning, and the miniaturization of circuitry and artificial intelligence, so we can have distributed and remote decision making, and an understanding of hypersonic aerodynamics and thermodynamics, so that now we not only have rockets that launch, but we have rockets that land. And this has dropped the cost of spaceflight, so it's already 25 times cheaper than when I flew in space. Imagine if anything was 25 times cheaper in a very short order, just how much that would disrupt, the way that you build your entire economic model. That's what's going on in spaceflight right now. And Canada, this is in Canso, Nova Scotia, just south of Cape Breton. We are building a launch site, taking advantage of our proximity to the Atlantic to be able to launch safely out over the Atlantic, with the Maritime Launch Service that's building a capability there. Within a few years, not only will we be flying along with international programs, but also Canadian engineering and capability in flying out of Nova Scotia itself. But the real change that's coming is this monster, which is called Starship, which is sitting on the launch pad down in Texas right now, and it should fly within the next month, as soon as the FAA gives green light to it. This will drop the cost of access to space by another factor of 10. So it used to be 25 times cheaper, will now be 250 times cheaper. So a ticket that used to cost $1,000 is now $4. And this is opening up a whole new realm and history of using space for human good, of taking advantage of all of that opportunity. And it's because of the relentless engineering improvements we made over the years. And NASA is looking at this vehicle, and in addition to Artemis, they're already buying these vehicles to take people to the surface of the moon. And because of our participation over the last 60 years with them, in fact, one of those same 4 astronauts is going to take advantage of the arm that we're building for the lunar station, Canadarm3, and the rovers that we're building to drive around on the surface. Canadensis here, run by Christian Sauerberger, who did his PhD in engineering here at U of T, is running the company that makes these lunar rovers. And as a result of all that, on Artemis 3, we're going to be walking on the moon, and on one of the subsequent missions, one of these 4 people is not just going to orbit the moon, but they're going to have a chance to be the first Canadian to walk on the moon. And we're not far away from settlement, a solar-powered, local water-using human settlement somewhere besides the Earth. We've been living on the space station for a quarter century, so it seems crazy, but it's not. And When the first peoples came to Canada, 18,000 years ago, that seemed nuts. You know, the glaciers were just retreating. They were in Siberia and trying to figure out, and a few of them made the big risk to cross what was the Bering Straits in there and come and start settling this continent or whatever. I guess 800 years ago, the first people built a good enough boat to get to New Zealand, or 1,000 years ago, the Vikings, or 500 years ago, the Europeans coming, or about 110 years ago, the first people getting to Antarctica. At the time, all of those things seemed crazy and daunting and beyond the edges of our technology. But what we did was we imagined some people were willing to take a tremendous risk, push the edges of our ability, and then once they discovered and identified what this new opportunity was, then we started backfilling all of the engineering and the capability to turn it into part of the human experience. And within our lives, we are going to have the Earth-Moon economic system, a continent bigger than Africa, with untapped geology and low enough in cost to get there to make it a practical part of what's happening. But who cares about the moon? What really matters, like Claire and folks were saying at the start, is this. This is what really matters. And what the university here is really trying to do is give people a set of skills to face the biggest problems that this spaceship is having to handle. You know, this spaceship with its own life support system and a limited number of resources just went over 8 billion human beings. And if you look at the birth and death rate, it's going to peak out at about 10 billion. So the biggest question of our day is, can this spaceship sustainably take care of 10 billion people with a good quality of life? To me, that is the quest. And the Dean mentioned the 4 pillars of the Defying Gravity program, and I agree with them wholeheartedly. I mean, we need to be able to make what we're doing on this planet sustainable. We already grow enough food for 10 billion people. We waste about 2 billion people's worth of food every day. So that's not the problem. But the way we generate power, it was good when there were only a few of us, but when we get to 8 or 10 billion, it's an unsustainable thing. We need technologies like are being developed down in the Fraser Valley by General Fusion, or one of the other fusion solutions maybe, to generate electricity. We have to grow food in a different way. Right now we're growing it essentially the same way that they did just south of the Himalayas 10,000 years ago when agriculture was getting invented in northern India. We've made refinements, but no great step increases in how it is that we generate food for each other. So the whole idea of one of the pillars of taking care of the planet, and then how do we integrate the cutting edge digital technology properly into this? How do we not let it just run away? How do we not just get fascinated with the magic and let it run us instead of us running it? How do we do that? And it's a big responsibility, especially with things like ChatGPT coming out right now. And on the medical side, the third of the pillars, how can we give everybody, no matter what particular set of chromosomal arrangements or physical configuration that they were born with, how can we give every single person the greatest opportunity to lead a full and fulfilling life? How can we optimize our medicine for that? And the fourth of the pillars is, how can we create the people to do those things? How can this school and the other schools like it generate the engineers with not just the ability to pass a test, but with the perspective of the world and the recognition of where they fit into it, to be able to do those things that are truly our greatest challenge, but also our greatest purpose. All right, I'm going to bring us back to Earth, and then maybe Mark and I remember there was a way to submit questions if you had questions, but I'll bring us back to Earth first. On my third space flight, I was the pilot of a Russian spaceship. This is business class on a Russian spaceship right here. That's Roman, the commander, and Tom, the flight engineer, and myself as the pilot. It comes hurtling down into the atmosphere, and we just use friction to slow down. And those are pieces of the spaceship going by the window. Imagine on your next flight on Air Canada. Excuse me, miss, what's that out the window going on? But you know, actually, I was sitting in my seat and I was looking out the window and, you know, watching the ship and everything, and suddenly there was a big bang! And I thought, oh, that's how I'm gonna die. It's been good, you know, what the heck. But the vehicle kept flying. All these sparks went by. I looked over at Roman and Tom, and they looked back at me and like, I don't know. And then there was another big bang and a whole bunch more shower of sparks. And I guess it was just like when you put a log in the fire, and there was just a little bit of air trapped in it, and it came popping out. But no one had mentioned this to us before we flew. But then you get down where the air is thick enough, and your parachute opens. Watch how hard you hit the ground.
And touchdown.
Yeah, right, touchdown. Yeah, this is inside here. You just slam back into it. It's like, take that, Earth. You know, you've been weightless for 6 months, and you don't just go, you know, gently or bang into it, but it's out on the prairies, you know, the steppes of Kazakhstan. It's always windy, so your vehicle hits the world, bang, and then it rolls end over end, takada, and rolls to a stop. And that little engineering achievement right there, Soyuz capsule, an amazing, tough little ship that could protect you, was our lifeboat for 6 months up there. I was NASA's director of operations in Russia. Imagine that. This little kid, growing up right around here, going to engineering school here in Canada, you know, later in life, I was NASA's director of operations in Russia. You know, it's just the opportunities that are available to all of us right now with travel and international trade. And sure, we're currently in big conflict with Russia. Russia's being led by a criminal despot right now. But that won't always be the way. When I came out of school, my job was to intercept Soviet bombers that were practicing cruise missile launches on North America. We were in the height of the Cold War. The politics, the geopolitics ebb and flow. But people are just people. And I lived in Russia for 5 years. Может быть, вы знаете, по-русски я говорю, наверное, кто-то здесь говорит по-русски. You know, I learned to speak Russian. I took care of a bunch of Russian people. They're just a bunch of folks like us. Some of them agree with their current politics, a lot of them don't, but what are they going to do? That's the lot they've been handed. They have a sense of soul and a sense of history that we have yet to develop in Canada. And what their current leadership is doing to them, they'll be suffering for at least a generation, financially and reputationally and personally. It's an awful thing. But when you come back to Earth, they're great. They greet you, they roll your ship around the right way, open up the hatch. They're like, "No, привет, мальчики, как поживаете?" You know, and they drag you out. It is like being born. You know, you were in this nice warm place, and suddenly someone reached in and yanked you out, and now it's cold and there's all these people around that you don't know, and it smells, you know, like Kazakhstan, and they hand you a sat phone, and now you're talking to your spouse, and you feel terrible. I know why little infants cry, you know, it's like, oh, you've been working for 24 hours already, and you're nauseous, and gravity sucks, and you know, you're sort of, but and you just want to curl up in the fetal position and cry. But the real question is, what do you do next? It's always the question. Everything you've done so far has just got you to the point where you now are faced with this choice. And did you gain the skills along the way? What are you going to do next? Are you ready for it? For the stuff that goes right, for the stuff that goes wrong. And I realized that, yeah, I felt like crap and my bones were weak, but I had also been through an almost unique experience in human history. Almost no one else has done this. And the richness of it, the things that I'd learned, the personal things, the professional things, how am I going to not squander those things? How am I going to make the most of those for me and for everybody else that I possibly can for the rest of my life? So I just stuck my thumb up in the air and said, I feel great. You know, I threw up, like some of you will later tonight, but but you know, what the heck? But I remember thinking at the time that I wish Owen Maynard had been there. You know, that guy who pushed himself to design the very first vehicles that were taking us away into space. And I really wish that that little 9-year-old boy had been there at the landing site to meet me. So I could have told him what it was like, what he dreamed about. And thank the 9-year-old kid that's inside you. Because the thing that fascinated them, the things that intrigued them, the stuff that they started dreaming about for when they turned into the person that you are right now, that's what has allowed you to pursue those things. And that little boy there, I would have just loved to be able to thank him for having the vision and the guts and the bravery to set me on the path that has led to the life that I've been so fortunate to lead. Oh, by the way, I write books. My new book is coming out. This is a shameless plug for my new book. The Apollo Murders is being made into an 8-part TV series, so that's cool. And this is the next book, and I just finished the copy edit yesterday. So this comes out October 10th. Mark, why don't you come on up and we'll see if anybody has any questions.